Hello, the objective of this video is to learn about linear functions and how to graph them. Linear functions are called linear because when you graph them, they form a straight line. Now, straight lines are not always going to be perfectly horizontal or perfectly vertical. Straight lines could be angled, but they're still straight. To not be straight, they'd have a curve to them. Technically, 2 points, any 2 points will define a straight line in space. All you really need is those 2 points, point A and point B. Connecting those two will form a straight line, and those 2 points can define that line. I'm going to require 3. Why am I requiring 3? Because if you made a slight mistake on this one, your line would go like this, and the values out here would be really, really wrong. So in order to prevent that, if you do 3 points and you find that 1 point goes like this, that should tell you something's wrong with one of your 3 points, and you may need to check your work. Okay, so we're looking for ones that should form a nice straight line with those 3 points. That's why I require 3 minimum. All right, here we have f of x, the function of x, is equal to 2x minus 3. And I rearranged the table a little differently than we did with function tables. Normally the function tables, you would have x, you'd have your function in the middle, and the y or f of x value would be out here at the left-hand side. Sorry, right-hand side. I did it this way because I'm going to be putting a graph over here that's going to cover this up partially, so I want to make sure I saw these values here. Normally, x, function, f of x to the side over here on the right. You get to choose your values of x, and as I said, you need to have a minimum of 3, so we're going to be putting in a negative value, because we always have to have a negative value. Let's say negative 2. 0 is easy to work with, and positive 2. Now I'm going to plug those into my expression. I have 2 times negative 2, which is going to give me negative 4. Negative 4 minus 3 is going to give me negative 7. Then I'm going to plug in 0. 2 times 0 minus 3, well, that's 0 minus 3, which is minus 3. Then I plug in 2. 2 times 2 is 4. Minus 3 gives me 1. So here are my 3 points to work with to graph. And here is my graph to work with. See how it covers up a little bit? All right, the first point is negative 2, negative 7. And remember, we have to run before we can climb up or down that ladder. So that means we have to move negative 2 to the left, and then down 7. 1, 2, 3, 4, 5, 6, 7. There's my first point. My next point is at 0, negative 3. 0 means I'm not moving left or right at all, but I'm going straight down to 3. 2 and 1 means I'm going over to the right 2, up 1, and there is my line. Now, here's where you should have a ruler and slap down the ruler and draw the line through those points with a ruler, putting arrowheads on both ends, because the function doesn't end at these points. It does continue in both directions. These 3 points just help me create the line. The line does continue, and I show that by putting the arrowheads on both ends. Without those arrowheads, this is not a complete graph. Don't forget, if you're given no graph at all, you should put an x for the x-axis, a y for the y-axis, and you should have the axes in there instead of just having willy-nilly all over the place. Never, ever do I want to see somebody giving me graphs look like this. Never. Use graph paper. You got to use it. on the homework is provided for you. On my tests or quizzes, if it's not directly on the quiz for you to use, I will provide graph paper for you. Is this fine for your notes? Sure, but graph paper for anything you turn in. Okay, let's look at the next function here. Okay, this time I've got f of x is 1/3 x plus 2. Now, if I go with my standard choices of -2, 0, and 2, I'm going to end up with fractions, because that 1/3 times my x value is going to give me a fraction. It'd be nice if I could choose my value so that I get whole numbers instead. Well, can I? Sure. Anything that's a multiple of 3 multiplied by 1/3 is going to cancel out the fraction. So I'm going to choose multiples of 3. Anytime you choose a multiple of the denominator, when you multiply by that number, it's going to eliminate the fraction. So I'm going to do -3, 0, and +3. Plugging in -3, 1/3 times -3 plus 2. 1/3 times -3 is -3 over +3, which is -1, plus 2 gives me 1. I plug in 0, the 1/3 drops away altogether. 1/3 times 0 is 0, plus 2, I get 2. Plugging in 3, I'm going to get 1/3 times +3, which is going to give me a +1 plus 2, which gives me a +3. Much nicer values for y than working with fractions, isn't it? So whenever you are given a function that has a fraction in front of the variable, you're going to want to multiply by some multiple, you want to choose your values of x to be some multiple of the denominator. Here comes that graph again here. I did erase a little bit. Fix that in there. First point is -3, 1. That's 1, 2, 3, the negative for the x, +1 for the y. So there's my first point. Let's do this in blue so that it shows up a little bit different here. And then 0, 2, which means I'm going to go neither left or right, but I'm going to go up 2 to here. And at 3, I'm going to be up at +3. There is my graph. Now I went a little crooked near the end there. This is why you should use a ruler for this. I don't have a big enough ruler for the board here, so I'm a little short on that, but you should definitely use a ruler when graphing. Now that's all you really need to do the graphing of functions. If you're having a little trouble with graphing the points, or a little trouble with the coordinate plane here, I have another video out on my YouTube channel. My YouTube channel, for those of you that don't know it, is mfunc4. On that channel, there's one called Graphing on the Coordinate Plane. And that will help you with graphing points on a coordinate plane. Thank you very much. See you in class tomorrow.